Hello guys, so continuing from where we stopped on functions, as I said in the previous video on functions, okay, we want to make our function, that is function 1, our function, if you recall, we want to make our function more robust, okay. Now by saying we want to make it more robust, we want to check if our function, if the function, oh sorry, if the object that is going to be imputed into the function, okay, is numeric. So we want to check if the object okay, imputed, if the object to be imputed into the function is numeric. Okay, so if it is numeric, something should be done. And then the next thing we are going to look out for is to handle cases of NA. Okay, so assuming the data set the person is dealing with has NAs, which wouldn't really help our function to work well, we're going to handle those ones as well. So we're going to do two things, and if there's time we'll do more things. Okay, I don't know how more, but then we're going to do more things. Yeah. So we said we want to check. Let me just cut this and paste it somewhere here so that we can all see what we're going to do. Our first objective is to check if the object to be imputed is into the function is numeric. Okay, so to do that, we're going to use the if statement, okay, to validate it. Okay, so we're going to say if, let's say, arg1, okay, if arg1, or we could say if is dot numeric, okay, arg1 equals true. To explain what I just said, I don't want to get you guys lost, so to explain what I just said, this is Jane's data, right? If I want to check if Jane's data is numeric, okay, there is an inbuilt function which is dot numeric, and I can use that to check if Jane's data is numeric. So since Jane's data is numeric, it says what? True. Now if I want, I could change Jane's data to a character and still use the s.numeric to check if it is a numeric or not. So I could say as.character. So I'm just piping this vector into the as.character function to convert it into a character. Okay, so now when I run to see if Jane's data is numeric or not, see what happens. It says false. Why? Because Jane's data is now a character. To validate that Jane's data is now a character, I would say is dot character Jane's data, and you'll see it says true, meaning that Jane's data is now a character, right? Good. So this principle we just used here is what we're going to apply in our function. Remember, our objective is to check if the object imputed into the function is numeric. Okay, so the clue is if. Okay, so we're going to use the if statement. So we're going to say if, okay, is dot numeric, if is dot numeric, okay, arg1 evaluates to true, right? If is dot numeric arg1, let's make it evaluate to false instead, not true. Okay, so if is dot numeric arg1 evaluates to false, meaning that if it is not a numeric, what should be done? Okay, we're going to stop, okay, and raise an error. So we'll say arg1, or we'll tell the individual your object must be numeric. Okay, and we give an exclamation mark. Okay, so here we validate, we are validating, so we validate if the object is numeric or not. Okay, so let me just explain what has been done here so that you guys understand. So in this body of code, we are trying to say that the moment the person enters an object into the function, this statement is to first check if that object is numeric. If it is numeric, it will evaluate to true. If it is not, it will evaluate to false, right? So if it checks and it evaluates to false, okay, we want to stop the whole process. We don't want it to proceed, okay? But if it evaluates to true, then this process is going to be carried out. So if it is false, it ends here and returns this error message. Okay, it will return this error message. But then if it is true, it proceeds to carry out the task. Okay, so now let's run that and take out this, because we are now coming to check if what we've done really works. So let's rerun Jane's data and now call our function. So our function is function1, and now we impute Jane's data. Okay, so see what happens. Because Jane's data is numeric, okay, it's numeric, it has imputed the mean, right? So now let's convert Jane's data to a character. So to convert it into a character, we will need to pipe. So we are going to pipe this into as.character. Okay, or you could decide to wrap each element here or each value here in quotes. Okay, let me just run this for you guys to see. So you see that because we said we've transformed it to a character, we have all your values being turned all your values having quotes. Okay, so now let's test it with our function. Okay, let's test it with our function, and it says error in function1, your object must be what? Numeric. So we're on the right track, right? So yes, what we want the function to do, it is doing it. Okay, it is doing it. So assuming the person now brings anything that is not numeric, okay, this error will be raised, and by so doing we are making the function robust. So we are building on the function. Okay, good. Now if you've come across or you've used data, you would notice that there are instances where there are NAs in data. So there are portions where nothing was recorded, so it's not available. Okay, good. So let's make the function able to handle such instances. Okay, let's make the function able to handle such instances. So I'm going to take the as.character from there and going to replace this value, which is 20. I'm going to replace it to NA, and then this will tell you why we need to um, um, you know upgrade our function. Okay, so now if I run this and give you Jane's data now has an NA, right? If we should subject this to our function, what do you see? It, okay, after running it gives an output as what? NA. But you're like, why NA? Because I have values in here. At least skip the NA and compute the rest of the values, right? That is what we want to do. We don't want our results to be NA. No. Okay, so we need to now, add that kind of uh, icing, okay, to our function, such that our function will now be able to handle cases of NA. Okay, so to do that, there is something to help us in R, which is na.omit. It's a function that omits NAs from an object. Okay, so we're going to use that function. Okay, so still going to go with the if statement. We're going to say if, okay, if what do you think we want to do? So you're going to say if s dot na, okay, equals true, then what should be done? Okay, if s dot na of the object is true, okay, what should be done? Okay, so we'll say if s dot na okay, of the argument, that is arg1, equals true, okay, what should be done? So what should be done is this: we're going to re-update we're going to re-update arg1, and in re-updating arg1 we're going to na.omit. Okay, we are going to omit na's from what? arg1, and then impute we're going to omit na's from arg1, and then update it with arg1, and then the whole process continues. But do you think this will work? This won't work. Okay, this won't work. Let me just run it and show you guys something. What do you see? It says error in if s dot na equals true. The condition has length greater than 1, right? Meaning that the object we are trying to test, if there is any, okay, the if statement can bulk it can bulk all the elements in the object and just pass out, or just give a conclusion that hey, there is any. Okay, so to do that, we want to handle each element in the object one after the other, so we're going to say if any. So that means that the moment the object is given into the function, okay, we want our code to check if any at all, any of the values evaluates to any. If it evaluates to any, then we can omit that any. Okay, so now let's go on with if any. So here, this is going to go not permanently. I'm just going to cut it, okay, and I'll bring if any. I'm going to bring the any function, and I'll put this at the back. Okay, we're going to put this at the back, right? So we're going to say if any of arg1 has an na and it evaluates to true, then this should be carried out, right? Good. So this is to handle cases of any. Okay, so observe the moment we run this now and run that now and run this, what do you see? You can see that we now have a result, okay, after the function computed what was required of it, right? So we're building on a function, aren't we? We're building on it because this was it. This is the current state of the function, the little mean function, okay, you wrote. This its current state. If someone should come and see something like it, like, what is this? But but then we are just building block upon block upon block upon block. Okay, good. Now let's say the final thing I will want to add now is probably a for loop. Okay, if you will remember, we had Isaac and Kwesi, right? And what I want to do now is what I'm going to do now is that I'm going to return this to its current state, and then I'm going to bring them back. That is Isaac's data, Kwesi's data. Okay, the reason I'm bringing them back is this. So we still want to make our function robust, right? Good. And how many objects do we have, or vectors do we have? We have 1, 2, 3. Okay, So it means that if I want to run Jane's data, I'll have to only quote Jane's data, because of course the argument we gave to, or the number of objects to be used or to be entered in the function was just one. We just said we only defined one, okay, arg1, okay, but based on what we have 1, 2, 3. So why don't we expand this? Okay, so I'm going to take off the comment from here, and then since we have Jane's data, we also have Kwesi's and Isaac, we're going to increase this up. So arg2, I'll call this, the next one arg2, and then the next one arg3. Okay, arg3. Okay, the same old function, nothing is changing here. We're just going to make sure that instead of we entering, okay, Jane's data, coming to clean it enters Kwesi's data, we want to rather give something like this: Jane, Isaac, Isaac's data, and let's say Kwesi's data. Okay, we want to now give something like this, and automatically each mean will be computed. Okay, that is basically what we want to do. So yeah, so because we want to attain this, okay, the goal, let me just make this the goal and take that from here and bring it somewhere here, okay, and bring it somewhere here. Okay, this is our goal, to impute all three objects and then get the means for each. Okay, so to do that, we're going to make use of a for loop. Okay, we're also going to create some lists somewhere, and yeah, that will be it. Okay, so let's start by creating our list. Okay, let's start by creating our list. So the first list object we're going to create, okay, is going to hold the argument arg1, arg2, arg3. Okay, those are the objects the list is going to hold. Okay, so first I'm going to call the object as hold. I'll say hold all list, or hold all args. Let me just make it hold all args. Okay, and we're going to create a list. Okay, so we're going to list arg1, we also list arg2, and we also list arg3. Okay, so the objects that will be entered by the individual, let me just space this, the objects that will be entered by the individual will be stored as a list. Okay, because they are unique in their own terms. Okay, we need to keep them in that accord. Okay, good. So hold all args. Now we're going to create a second list. That second list object is going to be, so out here, let me see, to hold all arguments. Okay, to hold all arguments. All right, so yeah, so just like I was saying, we need to create another list which will hold the results. Okay, so I'll create that object and call it, let's say, result list. Okay, and it's going to be an empty list, so I'll save this as empty list to hold the results after computation. Okay, after computation. Is that all right? Okay, so it means that once arg1 is computed, for instance, arg1 will be stored in the results list. Once it gets to arg2 will be stored in the results list. Once it gets to arg3 and it's computed, the results will be stored in the results list. Good. But you know, we need to have the user in mind, or we need to have you in mind, that if you enter, let's say, argument 1, argument 2, argument 3, and the results are given, at least there should be some kind of clue, okay, that would let you understand whose result you're dealing with at the moment. Okay, so to do that, we're going to name the list. Okay, so it's going to be every name would have its results added to it. Okay, so to get the names of the object or the results that will be stored in the list, we're going to create an object called names for, let's say, names for list results. So names for list result, and what we're going to do is that we're going to paste, okay, so paste, yep, we're going to paste, let's say, arg, okay, and 1 to the length of hold or args. So hold or args. Okay, you should understand what this means. If you do not understand, don't worry, let me just explain this. So we have 3 arguments in all. I could have just gone 1 to 3, right? But assuming we later want to expand this and we do not know the length the individual or the number of objects the individual has, it will be expedient for us to use the length, okay, function here. But if I should take this out and just bring 1 to, let's say, 8, okay, see what will happen in the console. You see that you have 1 2 3 4 5 6 7 8, right? And that is the same thing we are achieving with this. And these names are now going to be the names of the list, okay, the names of the results in the list. Okay, let's separate it by something. Okay, let's separate it by, let's say, an underscore. So arg will be separated from 1 by an underscore. Okay, good. I think so here is going to be names for list. Yeah, so I think this will be it. We now need to deal with our for loop now. Okay, we need to deal with our for loop now. So we're going to write our for loop. We're going to say for, okay, variable in vector. This is the syntax. Okay, but the for loop is going to do 2 things. Okay, it's going to first help us compute for the means, and it's also going to take the names and then assign those names to the list. Okay, so I could go with getting the actual values in the list object, but that won't really help. Okay, that won't really help. So the best thing to do is to make it sequence some numbers and then deal with those numbers instead, so that I can easily subset from both hold or args and names for list. Okay, so to sequence, I'm going to use the seclen function. So I'm going to seclen. Okay, I'm going to sequence the length. Let me just show you something. If I should sequence the length of 8, it's going to be 1 to 8, as you can see in the console. So if I am sequencing the length of let's say I'm sequencing the length of hold or args, okay, it's going to be 1 to 3, isn't it? Yeah, it's going to be 1 to 3. Good. Now that we have our for loop, let's play a bit. So for variable in whatever, okay, it means that since we have the length to be 1 to 3, so 1 2 and 3, the variable you see here in the for loop is going to now take the position of 1, going to take the position of 2, going to take the position of what, 3 after each run. That is why it's looping. Okay, so let's first subset our first element from the hold or args. Okay, the first element we want to the first object we want to deal with. Okay, so I'm going to create an object called hold temporary. So I'll say hold temp, and this hold temp, what it's going to do is that if I have hold or ask, I want to subset the variable. Okay, so meaning that hold or ask contains this list object. So if I'm subsetting from hold or ask, I'm subsetting the variable, and let's say the variable is 1, it's going to subset or bring out the first element, which is arg1, and that will be stored in the hold temp. Okay, so here to subset, I'll say to subset element from, or subset, sorry, the object from the list, which is hold or ask. Okay, good. So once this has been subsetted, what should be done? Okay, so what should be done is that the code we wrote here, okay, we're going to now harvest it. Harvest or take, which one? We're going to harvest the code. Okay, so let me just cut this. So I've cut this, and I'm going to paste this in the for loop. It's going to go in the for loop. If you can see, the for loop starts here, ends here. So I'm pasting it here, not outside the for loop, in the for loop, whereas the return is going to stay outside the for loop. Okay, good. So yeah, so now we have subsetted our first argument, our first object, held it in hold temp. Okay, so it means that this has to be changed. Arg1 has to now be changed to hold temp, hold temp, hold temp, right? Because this is now the current object that will hold every subsetted object from the list. So we're going to hold temp as well. We're going to hold temp. We're also going to hold temp here, and we're going to hold temp here as well, and we're going to hold temp here as well. Okay, so yeah, so this is it. We have this here, isn't it? We have this here now. Good. So once this is computed, it will be stored in the result1 object, right? And after it is stored in the result1 object, our final goal will be to store it in the list object. So what was the empty list we created? What was its name? It was result list, right? So we're going to take the results list. It's a list, and we're going to name the element in the list. So to name the element in the list, we're going to use the names for list object. So names for list results, and we're going to subset the variable, right? We're going to subset variable this way, and then impute the we're going to impute the result1 now into it. So it means that once the first object is taken in from hold or ask and stored in hold temp, it will check if it is numeric. If it is not, this is going to happen. If there are NAs will be omitted, and then we're going to sum the values. Okay, we're going to sum the values, find the length, divide, get the average, and then store it in the list object. Okay, so yeah, okay, we have this and that. So where is this coming from? Yeah, so that is it. So what are we to return? We are going to return results list and not results. Okay, so we're returning results list now and not actually results. Okay, so let's just scroll through, see that everything is well done, and well, let's go ahead now. Good. So we run this, our function, and then now we impute Jane, Isaac, and Kwesi. Okay, let me just rerun this again, and now let's call our function, and here it is. Excellent, done. Okay, so over here you can see that your arg1 is 4600, okay, and you can easily tell what your arg1 is. Okay, so my arg1 is Jane's data, my arg2 is Isaac's data, my arg3 is Kwesi's data. Is that okay? Good. So try out something for me. Okay, I'll end here, but I want you guys to try your hands on something for me. And yep, if you would see, or if you would observe, we started we started a function. It was, the function we wrote was very small, right? But since we are including some few checks here and there, few codes here and there, we now have, look at how lengthy the code is. Okay, if you're able to write this, count yourself an hour programmer. Okay. Yeah, so that is it. But what I want you guys to do for me is at this portion, okay, I want you guys to try your hands on it, do something. If you do not find it, if you encounter problems, you can leave it in the comment section. Okay, always use the comment section so that we'll know what is wrong with you, okay, and the challenges you are facing, so that we address it. Okay, yeah. So what I want you guys to do for me is here. Okay, here. Okay, let's say the person inputs arg1, arg2, arg3. Okay, and we first run arg1 and we have the output, or we have the result. But when we get to arg2, it is a character. Okay, since it is a character, it will stop and tell the individual that, okay, your object must be numeric. But the individual would not really know which argument in person, okay, sorry, which object in person has to be numeric. Okay, so I want you guys to think about this. Add something. It's just something small you need to add here. You're probably going to use either a cut function or a paste function. You're going to use a paste function or a cut function. It's up to you. Okay, so over here in this top thing, you're going to make it such that the individual can know exactly what is wrong. Okay, so instead of your object must be numeric, it should be, let's say, arg1, okay, should be numeric, or arg2 should be numeric, or arg3 should be numeric in case it is not numeric. Okay, all right, so take your time, go through the code, or go through the concept one after the other. Okay, go through the concept one after the other, and believe you me, if you are able to, write this code, like I said, you are no longer a you are no longer a beginner. Okay, so stepwise, okay, logically think, plan, okay, know why you are doing this, know why you are doing that, know why you are not doing this, know why you are not doing that. Okay, and you are good to go. Thank you very much for joining. Okay, I want you guys to like, subscribe, share, and comment. Okay, comment if you do not have a thorough understanding of something, and maybe we could, have a session together and see what how things goes. Okay, all right, okay, so thank you very much, and I'll see you guys in the next video, which will be how to probably read files into R, okay, and manipulate some files in R. Okay, so bye bye, see you.